if I remember rightly, Annie, I think you come from a finance background. Is that correct? Yeah. So extreme data's very interesting, especially from a financial perspective, because often that's the data that you're most interested in. So removing that could be really, really costly to your hedge fund, to your investment bank. Removing outliers would have been some of the things that helped us fall into a financial crisis back in 2008 and 2007. The fact of not seeing the outliers and the fact that mortgage default rates were rising and things like that. See, data cleaning is very much tidying things up and making sure that the data that you're trying to work with is in a state that can be effectively used by your AI algorithms, tools, techniques, processes. And then you can, as you've said, Alistair, there, make accurate conclusions from your data. But you need to make sure that what you're doing is appropriate for the type of data you're working with and for the task and the job that you're doing. Often people think that there's this whole data cleaning is just a standardized pipeline, when in fact it's really not. There's a lot to consider when you're trying to do data cleaning, and you need to make sure that you're processing it effectively, you're not removing outliers that would actually be interesting or that signal a change in the what we call the distribution of the data. If your data is evenly spread over a big area, or if it's really tight and compact and then you've got a couple of outliers, are those significant or are they errors in measurement? And often you can't know that just from the data. In fact, there's this fallacy that we think as data scientists, as AI engineers or experts, machine learning experts, that it's all in the data and we can just learn everything from that, and that's just rubbish. Because if we don't understand where the data's come from, then we can easily discount things that are really, really significant features. And we're going to look at an example of this later on. So Adam, I noticed you said that IPyNobe file doesn't open on the Mac. Don't panic that it doesn't open. We're going to come to how you open that later, and we're going to be using Google Colab, so a cloud-based or an internet-based programming environment to do all the programming. That way, it doesn't matter what computer you're on, whether it's fast, slow, whatever. We're just going to use Google's free resources to do our programming for us, and then everyone can run things the same. So it's really good for environments like this, but I'll come to that later on. Okay, so let's talk about data. So everyone can see the slides? Perfect, thanks everyone. So what we need for data analysis, we need well-structured data. Now, often data comes in a table, but it doesn't have to. Okay, so it can come in terms of a table where you've got different features or columns that tell you certain information, and then you've got rows that fill up that data table. So if it's people's shopping habits, for instance, you've got different categories of the things, say dairy products, bakery products, these things and those things, and it's maybe your Tesco's, maybe your Morrison's, maybe any other supermarket, and you want to know what each of your club card members are buying and how much they're spending. So your features would be each of the different things that you're interested in looking at. So dairy, bakery, alcohol, sweets, or confectionery, those kind of things. Each of the instances, though, would be customer, Ian, customer Khaled, customer Mariam, and they would say how much I'd spent in that bakery, in that dairy, and on alcohol and on confectionery and all of those things. And it would be different for each of the different people, obviously. Now, we'd want to know about the trends and the patterns in this and make sure that we can do targeted advertising to the right people. So it's pointless trying to advertise confectionery to Khaled if he doesn't buy any sweets, or alcohol to Mariam if she doesn't ever buy alcohol. You want to make sure that you're targeting your marketing and grouping your customers appropriately, and also classifying your customer base so that you can understand that base and then make sure your shops are stocked effectively. So it's pointless in my local Morrison's having certain products there, given the demographics of the neighbourhood of where I live. There is no halal section in the meat produce area, but ultimately in other shops, there's going to be a massive halal section depending on the demographics of the customers in the area. So the data will inform us of that. So from the information, obviously, we want to characterize what's going on and explain and tell the story. And this is one of the things I'm really passionate about you all learning throughout the course and throughout the hackathon and just in general working in data. It's all about telling a story about the data. And if you can't tell the story about it, you need to work out what on earth you've been doing in your analysis and who you're going to be telling about it. It's never just analysis, it's always what's the story. So you get reports, visualizations, and classifiers. Very sorry about that. So the data, or instances as we call them, are observations or samples from an entire population. That could be a population of customers, it could be a population of animals if you're a vet, it could be a population of anything really. It's just a set of different things that we're observing. Each has many features that are measurable properties or characteristics. Now, they don't have to be numerical characteristics. They can be characters or strings, as we call them, text, or any kind of features, really. What their favorite color is. That's, you can't numerically quantify that easily, but you could say blue, purple, green, red, and look for trends in data there. So we need to take a journey from the raw data to a single representation that we can then work with. Now, there are three basic encodings of structured data. I'm just going to jump all the way through. No, we'll stick to this. So tables, first of all. So these are comprised of what we call tuples. Tuples are a data format that are permanently structured and don't change. You can't update them ever. Okay, so it's a bit different to how you might work with Excel, for instance. So try and I know you can't see the screen. I'd be told people could see the screen before, but if anyone else is having a problem seeing the screen, please let me know. You might need to leave the call and just rejoin Charmpre or close the tab or Teams and then reopen it. So these are called data frames. These might have like customer IDs and things, what their name is, their hair, their height. So these are the different features, and these are the different observations or instances we'd call them. So that's a table, and the easiest narrative and parallel to this is like an Excel spreadsheet. Okay, so we'd work with data in a tabular format, and we're going to be doing that very shortly in our introduction to Python and programming exercises. Then we've got arrays. Now, if you're from a computing background, you will have heard of arrays. They're very like a table, except they don't have column or row headings. They just have numerical values in there. And arrays are really special because we can do mathematical operations with them, whereas you can't add two tables together. You can't multiply tables together or find the square root of a table like you can with a number. But with arrays, or what we call matrices or tensors, you can do maths to them. And if you can do maths to it, you can work on the data in it, and you can do AI models, machine learning tools, techniques, and processes to that. They're all mathematical models that are just applied to data information. So that's an array. And I'm going to move on and then come back to arrays in a second with a particular example. The final type of generally structured data that we work with in Python is something called a dictionary. Rather like the book that you might have on the bookshelf, like I have back there, where you've got a word and then the description of that word. A thing, description, thing, description. Dictionaries work like that. So you have the equivalent of the word, say type here, and then the description or the information to do with that type. And then you've got features, and you might have all sorts of different features that are there, and you might have some other factors as well. And you could have multiple different dictionaries for different people or for different customers, bits of information that you want, and then you can compare the things in those. But what it means is for each dictionary or each person, you've got the information in this kind of a item, information about that item kind of format. And we'll come to this shortly. We've got another example to do with cars later on. And examples for these, you might have heard of things like JSON, if you have any computing background whatsoever, but don't panic if you're not. We'll teach you about that in the first semester if you come onto the MSc AI. XML and objects as well. So just to jump back one to arrays then. So often people struggle to sort of understand what an array is, what it means to have a table that doesn't have column or row headings. But I have an example of something that's contained as an array that everyone has. I'm sure you have multiple of these all stored on your phone without even realizing it, that they are stored as arrays. And that would be a picture. Now, it might seem a little odd, but I guarantee you it is an array, and you have worked with it and you will easily spot what's going on. So if we take this rather awkward picture of myself, which is an array, and it's an array because it's made up of lots of individual elements that would be in a row column format, but it just doesn't have a heading of the columns or the rows. See, a picture is made up of multiple pixels, and which is a square, and each individual pixel has a specific numerical value to it. It's a bit of a lie, actually. It has 3 numerical values. It has a value for the concentration of red, value for the concentration of green, and a value for the concentration of blue, or RGB. And when you add up those, how much red and how much green and how much blue, you get a pixel, it's called. So this square here, or this square here, and this one is a higher concentration of red and blue because it's darker. This one's not got very much red in because it's lighter, it's green. Here they're all really bright, really low values of red, green, blue because it's really bright. And here they're all really high because it's really dark. See, when we zoom right into a pixel, all we've got is just in essence, the square of a table. It's just that table doesn't have any headings or columns. Does that make sense why this picture is technically an array and not a table? Okay. Alistair's convinced. Anyone else? Or want me to explain that one more time? Perfect. So that's good because I can get this awkward picture of myself out of the way then. And we'll get back on with the slides. Okay, so tables, arrays, and dictionaries are the general standard data structures of structured data. With structured data, we've got multiple processes we need to work through to get through any data science project. We need to acquire the data, we need to wrangle it, integrate it together, clean it. Once it's clean, we can apply our machine learning tools, techniques, do the reporting, visualizing, tell the story of the data, job done. But we've got this big chunk here to do first. And historically, and I use that word historically quite importantly here, it's always been about 70 to 80% of any data science project has been consumed with these 4 stages of information. Actually using AI models, tools, techniques, approaches, and the fancy stuff that makes the news, less than 20% of a whole project. And then you've got some reporting and some visualizations and stuff to do at the end. But this is actually the bulk of information that's done and work that's done to data for part of a data science project. There are the equivalent now of software houses in India and in China, more so in India at the moment. There are factory buildings full of people sat in front of a computer, acquiring, wrangling, cleaning and processing data, sometimes even just labeling data. If you're Google and you want to teach your nice car to drive itself, you need lots and lots of data to train the AI models on, so it knows that this is street lights and this is a bike and this is a zebra crossing, and I need to behave appropriately around those things. So in order to do that, they need to have the picture, and someone needs to have put a box around the street lights and gone, street lights, person, zebra crossing, tree, building, sky. And that's thousands upon thousands upon thousands of people's job, day in, day out, to take pictures and to label them like that. So acquiring the data. Then they need to join them all together, because you need a video to actually show it. You don't just give it the pictures. You want a video so it can understand how things move through time and not just think every time it takes a photo, what am I doing? So that would be the wrangling part, integrating it all together, and then the cleaning of that as well. See, if we've got lots and lots of text, it may be that we can format it as a single table, or it may be actually that we've got multiple different tables that we need to join together and merge and mess around with. We've got multiple sources of information to draw on to then do any smart machine learning inference about. Or we can just get everything from a database. Maybe that's on the internet, maybe it's locally, but a database that's stored lots of information and just pull that out into a nice table so that we can work with that. We always want to leave what's going on in the database as a secure, stable bit of information. And it's been said recently, data is the new oil. Okay, it's really valuable. You don't want to risk, messing around with it too much. So you take the data out of the database into your Python programming environment and then start working on the structured data there. Okay. An API, as the acronym that's input here, you'll learn about this more in the start of semester one with the MSc AI, but in essence that just allows things like programming in Python and Java and stuff to grab data from a database or from a website. Twitter has famously recently changed how people use its API. It used to be free for research. It used to be very low cost or free for lots of companies to use. They've changed it to charge a lot more money for people to use the Twitter API, which means we can't do research on Twitter anymore because it would cost far too much money for academics like myself to try and get the information out of Twitter to do stuff with. Whereas before we might have tried to look at the, people's sentiment or their feeling or positivity or negativity around an election, how they were talking about it, or looking at social clusters and groupings of people who voted for Democrats or Republicans in the American election and things like that. But we can't do that anymore because it costs too much. So once we've acquired the data and wrangled it together, and I'll come back to wrangling in a second, then we want to integrate it and extract relevant features from that, clean it, and then we've got data we can actually work with to then do reports, visualizations, classifiers, and things like that. So there's an activity here, and at the end of this, I'll put in the Python notebook for this so you can all run through it, but it is very much a click and go. So you don't have to do anything to this. There's a structuring data in the context of a web data task. And this is a good activity for you to do afterwards. Okay, what I'm going to do is just shrink the slides in a second and work through the code rather than work through the slides. But in essence, we've got a hypothesis here for a data science project. And little projects like these are brilliant for you to undertake and build up a little profile for and a little portfolio. So you can put this on your own website, on your own GitHub profile. Again, we'll talk to you through how to do this to build up your portfolio as a data scientist or a data engineer, and then that'll help you get jobs when you graduate. So if we've got a hypothesis here, and we always need a hypothesis to work with because we need to know what we're actually going to be working on the data for and testing on that. So our hypothesis here, CEOs of major companies are typically in their 40s and older. Out of curiosity, anyone think that that's a void hypothesis or any problems with that, or we're all in general agreement that that's probably the case? I have to say, originally when I started doing these slides and the activities a few years ago, I used to think that sounded really old. And as I get older and older, I think, oh, it's not too old. So anyway, the way that we're going to analyze this is identify, first of all, who the top companies are. Then we need to identify who the CEOs of those top companies are. Then we can find their ages. And when we've got all of their ages, then we can test our hypothesis. Is Tim very old? Okay. Again, I might just be getting older and older. So what are the issues? Where do we find authoritative, reliable, and useful data on this? How we're going to load it in? And how can we link it together? So we could work with data sources like a big list of companies and categories in a comma separated variable file, or CSV, which often when you open it on your computer, it'll open in Excel and make it look like an Excel spreadsheet. But there's a subtle difference there. We've got an example for our little programming activity shortly. Then a table of companies and CEOs in a Wikipedia page. And Wikipedia pages are web pages, and they're written in the HTML format. So you might notice on most of the websites you go to, although it says .com, if you look at the whole website at the end, it is a .html or a .php. Very few websites are anything other than those. So it's pretty much all websites are written in that format. Then we need to get content from the HTML pages on the people when we know who those people are that are the CEOs. PHP, thanks Annalise for pulling that up, me up on that. So PHP is for dynamic web pages rather than static. So static web pages have information on, and you can click on links and things, and that's it. But PHP pages are dynamic, so they get information from a database or they react to what the user is doing. So it's almost like a two-way show of things. Facebook is written in PHP. Like it's the biggest example ever. Like, so you log on to Facebook and it gets your profile information from their database, but also interacts based upon your likes and the information and things that you do. Okay. Not all big social media websites are written in PHP. It was a bit of a weird choice for Facebook because they could have done it in a far more efficient way, but it's the quickest, cheapest way of hiring all the developers they needed to work on it quickly and efficiently. So they just ran hell for leather into PHP. If they were doing it again now, I don't think they would do it in PHP. So it's a programming language, in essence, that makes websites. So what we're going to do, you've got the slides for this, but rather than working through those, I'm just going to jump straight to Google Colab. And I'm first of all just going to talk through what this set of slides and activities is doing, which I'll share with you later on, and then we'll actually do some programming all together very shortly. So first thing I'm going to do, we'll just start from scratch. So just gonna Google, I'll go to google.com. I'm at Google and I'm going to search for Colab. And the first link there is welcome to Collaboratory. Now it'll do this because I'm logged into Google. If you're not, there were some slides yesterday that Mariam introduced and Ali introduced, I believe, that tell you how to get yourself a Google account, even if it's not through a Gmail or personal address. You can use it through a company email address and log in. But we can talk through that again in a moment. Then I'm going to upload, and I'm going to choose the file, and it's going to be the data wrangling Python notebook. Later on, we're going to work with this basics of Python notebook. So I'm going to open that. It's going to load up my Python notebook, so the activities and the coding that I've previously done and set up. And here is our Google Colab environment. And it looks like a right mess, and it's got some sections and things that you can jump to, which make things nice and easy for working out what we're doing. But first of all, I'm just going to hide this, and we're going to focus on what's going on here. Just to make things a bit easier, I'll zoom in a bit. But so tell me if that's too large or too small for everyone to see, but hopefully it's all right. And before we get started, I'm just going to clear all outputs and make it start from afresh rather than load it in where it's already done some of the work for us. Now, Colab files are a .ipynb or IPython notebook. They're different from just .py or Python files because Python files are just code. For things like hackathons and introductory programming activities, I like to use these .ipynb and Google Colab because we can have text sections that introduce things and code sections. And you can break up your code into what's being done and explain what's happening there. And it's much easier to fault find or to mess around with the code and to understand what's going on. And for you to be able to review this later on as well. rather than if I just go, here's 1,000 lines of code, just hit run and it'll work. I promise. Okay. So we're going to be talking about data wrangling. And in essence, data wrangling is getting information from multiple sources and shoving it all together and making sure it all fits and works together. Sometimes it's a nice painless process. Normally, it's like trying to put a tent into a tent bag. And anyone who's been camping will know exactly what I mean, where you've got a ground sheet and you've got a tent and you've got an inner tent and you've got tent poles and you've got pegs and you've possibly got other things that need to be shoved into this tiny tent bag that's just a right nightmare and you end up stomping it in. Sometimes it's like that. So we're going to start and test this hypothesis about whether CEOs of major companies are typically in their 40s. And some of this I'm going to explain lots of, and some of it I'm just going to sort of gloss over and you can go back to in your own time because it's not massively relevant. I want to get to you guys doing some hands-on programming of your own. So the same way that if I dabble a bit in DIY, and if I'm going to go and do a DIY job, say I've got a hole in my wall that I need to fill in, I'm going to have some raw materials that I need to work with to fill in that hole. Say I need plasterboard or some wood to fill the hole with. So I've got that data or that information to fill in this hole, that job that I need to do. But before I can do the job, I need to go to my garage and get all of my tools. And rather like the tools like hammers and saws and drills and all of those things, Python has loads and loads of different tools and things that we can use and just call on. Some of it will be natively in Python on this Google computer that we're connected to at the moment, and others we need to install and tell it to go and get those to start with. So I need to go to the shop. The analogy would be me having to go to my local DIY or hardware shop and go and buy a specific drill bit or a specific thing for cutting tiles to do my DIY job. So it needs to install those and prepare those first of all. Then we can go to the garage and get those tools. We can load them in, and then we can actually start to do the job that we need to do, filling in the hole in the wall. So what I'm going to do is connect to a Google computer first of all. This code isn't running on my machine. I'm in a web browser, and just get rid of that so it's a bit easier. I'm connected to a Google computer. It's a Python 3 Google Compute Engine backend. It has 12.68 gig of RAM and 107 gig hard disk. So tiny amount of storage compared to what your computers will have, and a reasonable amount of processing power RAM for storing information there. They're really cheap computers, and Google has thousands of them, and it lets you use them for free. It's great for simple programming problems. As soon as you've got lots of data or a big model that you need to run or a big AI commercial task that you need to do or something secure, you have to do it on your own machine or some other setup. But for teaching and for getting used to things, absolutely brilliant. So I'm connected to there, and we can see that it's got a nice tick, so we know it's all working. So I'm going to start off by telling it to go to the hardware store and go and buy the tools that it needs to do the job. In essence, install all of these different libraries and things so that it can do the job we need it to do. And that's just going to take a minute, just like it would if you were installing something on your own computer. But you'll see I pushed play to run this section, this grey section of code, and it's put this white box underneath telling me exactly what it's done. Installing stuff, getting the requirements of stuff, all that boring jazz. I don't really care about all of that because I know it's going to run. All I'm waiting for is it to finish and stop the wheel turning and saying it's done its job. Then what we're going to do is go a bit like going to the garage and getting all the tools. It's got to go and import all of the tools and techniques and things it needs to be able to actually do the job. We could tell it to go and import everything, every tool, technique and things, but that would be a problem. In the same way that if I'm just filling a hole in the wall, I don't need to go and get everything from my garage. I don't need to go and get my ladders if the hole is really low down the wall. I don't need to bring my saw if the wood is already the right size. Okay, the more things that you unnecessarily import, the more computer space that you use, the slower it gets at doing the task, or it may even not have the actual capacity to be able to do the whole task, and then it will crash. So we need to be a bit conservative when we're loading things in. So we're loading just the things that we need to be able to do this task. And remember, this task is getting information from Wikipedia, from those HTML or web pages, and then wrangling it together, integrating it, cleaning it, and then coming up with a visualization at the end to say whether or not we believe that more CEOs are over 40 or under 40. So any questions so far, or are we all cautiously following along? Okay. So whilst this is just taking a moment, okay, we're all done. It's run that. It took 2 minutes to install everything, so we can move on and run the next part of our code. So what this is going to do is get all of those tools, libraries, techniques, and things in and make sure that we can do the job that we need to do. I'm not expecting any of you to know what any of those things are. I can't tell you what all of those are to start with. Fortunately, someone has put in these green text, or as soon as you put a hash in the code, it means that it's just what we call a comment. So it just tells you what the line of code underneath is doing. Alistair, yep. So the file that I've shared with you is the activity we're going to all do next, Introduction to Programming. Here, I'm just showing you about data wrangling, first of all. Okay, so here is a line of code that's going to acquire data and get the data from this website, first of all, the CSV file it's going to get. It's going to create a mini database to hold this information and then put it all together. And we'll notice it's an absolute mess. First of all, there's loads of stuff in here that we don't need, but this is what it looks like. Some links, some names. I don't know what all these fields are to start with, but I know that in there somewhere is the information that we need to do our tasks. And we're going to get the HTML table, or the data containing information about CEOs. So we can start to see the companies, and it's getting more like what we're expecting to be able to do for the task at hand. Company, who the CEO is, what their title is, and when they were in that position since. So Julie Sweet was Accenture CEO, or interim CEO since 2019. Okay, and there's some notes there, information about who they maybe succeeded or where they were from before. Okay, so we've got 185 rows in our data set here and 6 columns. So 6 features or bits of information that we want, and each row is a different company. For some reason, the WWE and Yum brands is in there as well. Now we need to try and extract the structured data. So what this is going to do is to go through all of the Wikipedia pages and collect the information and then put that into a little database for us. And you see all I'm doing is just going down section by section and hitting play on the preset bit of code that it's doing. Okay. And you can see that some of them have been found the information for that CEO, and others there's just no information. As soon as it hasn't found a Wikipedia page for a person, it just says not found. So we need to clean that information out of the data set, because if we can't find them, we can't say what their age is. The database is stored on this Google computer. So it's not even storing the information on our computers, it's all on Google's machines. Which is why if you're dealing with secure information or data, you can't use Google Colab. But we teach you about how to do things on your own computer on the course, don't we? Okay. So we're going to get to the point where we've got the name of the CEO, the web page, and when they were born, that information. Yeah, it's all local, it's not BigQuery, Alistair. Now we've got that information, we can start to manipulate the tables. or the data to get it into what we need to do. So we've got the name and when they were born. That's the core bit of information that we need. But we've got some bits that say NAT, or no information for that. So we need to get rid of those and clean those out and to sort it all. Now we need to make sure that we can get rid of this whole hyphens as well in their names, or any underscores and things, because we don't want their underscores in their names. That just looks like a bit of a mess. So we need to clean and process that. And it's starting to look a bit better. And then we can put it as their clean name back into the database. So see, before it had underscores in the names, now it's got those cleaned out. The reason that it has underscores is because when you've got a Windows computer or a Mac or a Linux computer, they treat spaces between text differently. And if you tell a Windows computer to find this person's name that's got a space in the middle, it might be able to find it, but the exact same line of code to tell a Mac computer to do that won't work. So it's better often to not have spaces in between people's names and information. You just put an underscore in normally. But for actually presenting the information, we want the space, because that looks a bit weird as a person to read, whereas we want the space in there. I'm just going to run these, and we're going to see we've got all of the information for their clean names now. We can check whether or not someone's name is Kumar Birla, and we'll see it's false for nearly everyone apart from this first one here, which row 1. Notice that for some reason Python starts counting rows at row 0. It's just the way it's set up. It's just one of those things you have to get used to, but row 0 is the starting one, and then row 1. So I'm just going to run through the last couple of lines here, where we put the information back into the database and we can start to join it all together. So we've got now a database that has people's names, their companies, and when they were born. We've still got that information when they were born that's not got any data in, and we need to deal with that fact. So we've got their clean names, and we're going to process that. Now it's turned their date of being born, which was in this format where it was just text, and it's turning it into a date, time. Obviously, we're going to assume that they were all born just on that day. We don't know what time they were born, and we don't really care. What this does mean, though, is if it's text, you can't easily say whether they were born before a certain year, because we'd have to look at the text. If it's a number, like a date or a time, we can see, is it less than this date or time? Much easier to do mathematical operations on it then. And notice that NAT has just turned to none values now. Still need to get rid of them, but we can deal with them much easier. Now we're going to join the database back together and clean it here. We'll see that there's an error, and it found an illegal name, someone who had a name that we shouldn't have been using here, where there's percentages inside the names and characters that we can't deal with. So we're just going to remove those and clean those out of the database. If we keep doing that and process, I'm just going to skip on to the relevant bit. So we've got that now all sorted in a nice format with dates that we can work with, and we can visualize the results. So we've got the data. We're going to group it by their ages, sort it by when they were born, and group it by their decade. And finally, after about 10 minutes of running the pre-computed code and the setup on this data and of creating a database, merging together the Wikipedia article and the data for the companies, and then the CEOs, and then their birth dates, and then sorting all of that and cleaning the processing, we get to this graph. What does the graph tell us? Do we think our hypothesis was correct? Yeah. Yeah, thanks, Rosalie. Thanks, Annalise. Yeah, absolutely. So our hypothesis was that there were at least over 40. So that would put them in the 1960s and 50s categories. Well, yeah, most people are. Someone appears to be in the 1920s category. So I would query that. I'd like to investigate who thinks they were born in the 1920s. But as a simple test, yes, we've proven that. So I'll share this code with you at the end of the session so that you can run through it yourselves and get used to the idea of Google Colab in more detail. But before we do that, there's going to be, yes, I suppose the 80s is starting to qualify well. Again, feeling very old, thank you. So we're going to work now on the Introduction to Python 1C file that I'd shared with you that's in the archive. So for those of you who've managed to unzip that or uncompress that, what you'll need to do, and I'll just get my toolbar back up. So I'm going to start a new tab and just go to Colab. I'll just Google that. And I'd very much like it if you can do this alongside, but I appreciate for some of you that might be a bit difficult with the setup and how you're monitoring, but it'd be really good experience for you if you can. And here's a notebook that we set up specifically for you to run your own lines of code and to be able to play about with it and understand that. So I'm going to go to Colab and I'm going to upload a file, and the file I'm going to upload is the basics of Python.ipynb. So I've uploaded the code. Can I just get a show of hands if you're going to do this alongside, so running the code alongside, and whilst I'm going to be talking this through, just if you want to raise your hand, so that I can at least get a count and an idea, and I'll know then how much I need to slow down if there's issues along the way. So I'll just do it again. So if I go to Colab, there, click the link, and it opens up this square box first of all. It starts on recent, but if you move over to upload on the right, then you can click choose file and it'll choose something from your downloads. Excellent. So we've got Andre and Tariq. You're going to be doing this alongside. Rujil. Perfect. Annalise, yep. Mona. Okay, great. So you go to the upload, choose your file and upload it there. And it should look something like this. So I'll start by connecting and making sure that I'm on a Google instance. And this is the standard aspect of Python. Okay, it's not a all-inclusive explanation of everything you ever need to know about Python. It's rather basic in parts and might seem a bit advanced in other parts. Don't panic though, because this week is just about you getting to use your first few lines and to use the ideas of programming and testing and to understand what you might be doing more of on the course if you come onto the MSc AI, and you can mess around with it more and do your own research to prepare for that. So the first thing to do with any programming language, if you look at any programming textbook, is they end up getting information printed out by the computer. Sometimes this can seem a bit pointless, but it just means that you've got your code is actually running, and it tells you how to teach you how to get the information out that you need from it. So the first thing we often do in any programming activity is print hello world. So what I'm going to do is click run, and it prints out the text hello world. We know it's text because it's got quotation marks around it. If I take those away and then click click play, it's going to crash because it thinks it's looking for what we call a variable. So think maths, because that's programming's impact in implementing mathematics as far as we're concerned for AI. Okay, Rajil, you might want to refresh the collab and get it to look again, or do it on a different browser if you've got Safari or Chrome or Firefox, and just give that a try. So variables have information about them and have a specific value, and hello world, it looked for that and didn't have a variable called that, so it couldn't print anything. So if we wanted to print out text, we print out things in quotation marks. So remember I said it's implementing maths, and Python is great at working with mathematical operations and things, and that's what we want to use computers for. They're great at it, and they can do it far quicker than us, so best to get them to do it for us. So we can do additive operations, like 5 add a half is 5.5, obviously. We can do multiplication. Now multiplication isn't an X, and we don't have a times button easily on a keyboard, so we use the star operator. So 276 times 52 is 14,352. If you want, you can check it on a calculator, but I'm almost certain that's correct. So with all of these activities, after the session, or even whilst it's going, if I'm going a bit slow for you, mess around with them. Okay, change the values and see what it does. Okay? It's all about you just getting hands-on experience at working with things. Now, Python is great at working with data because of how it handles sets of observations. Now, this can be done really simply using what we call a list, which we set up with square brackets. And lots of activities and things in Python that people code up use lists. They're really flexible, and they've just got lots of information. So if we had the numbers 1, 2, 3, 4, 5, and we wanted to store them in a list that we could then use later, we just put them in square brackets and put a comma between each of the different elements in a list. So if we are Jaguar, for instance, and we've got 4 cars that we're trying to sell at the moment, the XE, the F-Pace, the XJ, and the F-Type, very much an aspirational thing at the moment in the cost of living crisis, but we've got a list here that has the names of these cars, and remember their names, their text, so we put them in quotation marks. We want to be able to use this information, this list, and to be able to potentially modify it later on. So we're going to store this as a variable called X. Really affectionately called X. So X equals a list, because it's got square brackets with the names of these 4 cars in. And if we want to print out all of the cars that we have, all we have to do is say print the cars are, and then a comma, and then tell it to print out X. And it does that, it will print out all of those. If we run that, it'll say cars are, and then we've got the list printed out. The great thing with lists in Python is that they're really easy to manipulate, to edit, to manage, and to mess around with. So if we wanted to say, oh, we're making a new car, we're making the E-type now, all we have to do is do x.append. Append means just add it to the end. E-type. So if we do that, and then we print it again, you see it's first of all printed out the cars here, because it's run this line, X is this, then it's printing it out, then it's adding E-type to the end, and then it's printing it out again. You'll notice E-type's at the end. Have a go messing around with that, change it from E-type to something else. Doesn't have to be a Jaguar, you can mess around with whatever type of car you want. So that's how we work with lists. You can start them, we can append or add information to them, we can delete information from them, we can edit information at specific elements of them. So edit the second car, the F-Pace, or the third car, the XJ, and say we're not selling that one anymore, delete that, remove that, or change the name of it because we've got a new marketing thing that's going to change the name and make it sound all new and snazzy. So this is a really simplistic use. But what if we need to use the variable to have calculations saved? For instance, the car prices. So let's look at the prices first and see what would happen if the chancellor decided to cut VAT on new cars, i.e. take off the 20% value there. To make this change, we need to adapt the value in a list requiring what we call a loop. So, and are you on a Mac or on a Windows? HP, so that'll be a Windows machine. So for me, it's Shift 3, but it might be on the right-hand side near the Enter key, somewhere around there. Okay, so what we're going to do in this code is create a list that has the set of prices, print it out to make sure that it's definitely got the information right, and then one by one update the prices that are going to be cut down by 20%, and then print it again and say these are the prices without VAT. So we're going to start, just of all, rather than worrying about the E-type, we're going to just worry about running with the XE, the F-Pace, the XJ, and the F-type. And you'll notice all I've done is put a hashtag back in front of x.append E-type and the printing out there. So we've got, I put a hashtag in there and that's stopped those lines of code from running. Really useful to do, but also you can put a hashtag in there and add in a line to explain what's going on in a line of code above it. So these are the prices of those cars. So the XE, and I just Googled these, again, prices are probably a couple of years out of date now, but the XE, the F-Pace, the XJ, and the F-type. Then we can print out what they are, and we're going to print what the prices are, and then the prices. Then we're going to one by one edit those prices, and then we're going to print out again. So to edit them one by one, we need to do what we call a loop. And this is like one of the most common foundational principles of computer science. If you've got lots and lots of information or data in some sort of format, whether it's a list or a table or whatever, and you want to do something to all of the data in that, like remove the VAT, you can't just tell it, well, just divide it all by this value. What you need to do is go one by one to look at the first one, divide it by 1.2 or take away 20%. The next one divided by 1.2 or take away 20%, and the next one, and the next one, and the next one. See, computers do operations one by one, or we call sequentially. So if they're doing operations in a structured order, then we need to tell it you need to loop over and go and look at the first bit of data and then do something to it, and then the second one, and then the third one, and the fourth one, and the fifth one, and the sixth one, etc., all the way down. And that's called a for loop. So the way Python that uses loops is telling it to say for index or the element, the row, whatever that might be, in a specific range of information, then you do something for that. Okay, it took me about a year to get comfortable with for loops in Python, despite having learned other programming languages beforehand. Okay, I'm not the best programmer by any stretch of the imagination, but please don't panic. I used other loops and ways around getting into for loops because I just didn't like the way they were run. And it's very much just you've just got to run them over and over and get used to them. So what this does is says it will make an index number in the range of the length of the prices list. So prices has 4 elements. So the length of prices is 4. Range of length of prices, all that's going to do first of all is going to go 0, 1, 2, 3. So it's going to be allow index to be 0 and get value, like price is 0, then price is 1, then price is 2, then price is 3. Remember that Python considers row 0 to be the first thing. It doesn't go 1, 2, 3, 4, it goes 0, 1, 2, 3. Good question, Craig, and excellent answer, Tariq. Thank you very much. So when we run this line of code, all it's going to do is say these are the prices to start with. So it's printed out prices, and then it's looped over all of them and divided by 1.2. And it's got that. Now the keynote, if you might have noticed that I don't just say prices at a specific element of the prices list divided by 1.2. I've got an int around that. And all that means is the int with the curly brackets around it means that whatever is done inside these brackets, it's going to turn it into an integer, so a whole number. I don't want any decimal points cluttering up my marketing material and things. I just want whole numbers. Okay. So is that clear how we've got the information in a list, looped over it one by one, and then printed out again? So Namagiri, it's not a step function mathematically, but if you think from a computing point of view, is stepping one by one through the index. Yes. You will get used to it, Alistair. Don't panic. It's really confusing. It's a bit confusing at first and takes a bit of experience to get used to, but actually it's far easier and more powerful than in most other programming languages. So if anyone's heard of other languages like C++ or C, as they're like really like fast and efficient and hard to code in languages, or harder to code in, their loops aren't as effective or as powerful as Python's. They're not as flexible, although they're quicker to write. They're much more restrictive. Whereas Python, you can loop in really interesting, weird ways to get exactly information you want from your data. So someone mentioned earlier that a dictionary might be a more appropriate way of storing this information. So that's what we're going to do. Absolutely. But I wanted to introduce lists first. So you're jumping the gun slightly. So what we're going to do, no, Tariq, no apologies. So Craig, are indexes anything to do with vectors? You can think of a vector as a list, and then yes, absolutely. Craig, good point. So for anyone who's from an engineering background who's heard anything to do with what we call vectors before, vectors can be thought of like lists from a programming point of view, where they've got a set of information that's separated for each of the different dimensions, as we call it in vectors, mathematically or geometrically, and all you want to do is get the information from a specific index of that vector and then edit it. So yeah, absolutely, Craig, you can think of it from that point of view. Okay, so we're going to create a dictionary. And this dictionary is going to have the car name and the price for that car. And that's all it's going to be stored as. Nice and simple. And this is how actual car data formats and data structures worked originally, when they didn't want to work with databases and they didn't have too much information back in the 80s and 90s. So you create a dictionary that has nothing in, and these weird curly brackets for create a dictionary. Square brackets make a list, and the curly brackets are for functions or things that need to be done on your data and information. So cars is going to be a dictionary, and the way that we create information or fill it really efficiently in Python often is by just creating something that's empty dictionary, and you can create an empty book and then you can start to fill it. And this is the great thing about programming. It's not like making a book or like these standard old-fashioned ways of working with information. So cars is a dictionary that's got nothing to start with, and then we're going to loop for over all the prices, and we're going to add to cars the car name from X. Remember, X had those 4 car names in, and then we're going to add the price to that, and then we're going to print it out and you'll see what it looks like. So we've then got a dictionary, cars, that has 4 bits of information in, or 4 observations. And there's a really important point to labour here. It has 4 data points in here. It might look like it's got 8 bits of information, but it doesn't. These bits of information are tied together. So the XE has a price, the fpace has a price, the XJ has a price, and the ftype has a price. It has that bit of data. We don't have 8 data points, then we've got 4. So now we've got a dictionary, we can adapt the individual price without just using a for loop and make things more efficient really easily. So if we wanted to cut the price of the XE car by £500 due to promotion, we could just say the cars XE is going to be the current price for cars XE minus £500 and then print it out. So if we do that, we'll see that the XE is now £500 cheaper than it was before, and everything else is unchanged. So we've looked at lists and dictionaries now as standard data types, and for this example we were okay using lists, but if we had a large data set and we wanted to change the elements, it would be really cumbersome to use just loops and things like that. So we'd want to use arrays, which are part of the NumPy library. Then we can get the computer, rather than writing our own for loop, we can get the computer to just do its own for loop for us. So to make an array, we need to import this NumPy library that will be able to make arrays with data that we can shove into it, and then it can do operations for us efficiently. And a lot of programming is working out how you can get the computer to do its job efficiently for you, rather than you having to write lots and lots of code yourself to tell it what to do. Sometimes you want to tell it exactly what to do because its own idea of efficient isn't efficient. But on the whole, someone's written an efficient way of doing the job. Okay, a lot of the AI course that you've hopefully are going to be coming onto from September is about understanding what the tools, techniques, and approaches are that someone else has spent 100 hours or 1,000 hours writing and creating, that you can just import, use, and then look at the results from. You need to know if you can rely on the work they've done, but chances are, if it's a standard library in Python, it's been done right. Not always, but chances are. It's about using those tools and techniques. It's not about you spending 100 hours writing your own code that someone else has just done the job for you. That no one's going to pay you to do that. Okay, there's just no point. So we're going to import NumPy. We're going to create an array or prices array, which is going to be a NumPy array with this information in. And then we can do simple things like just rounding and taking off the VAT in one line of code. Whereas before, to take off the VAT, we had to loop over all the values and then tell it to divide by 1.2. So much easier to do from our point of view there. Now, what we can do with an array as well is we can have multiple different columns in our array. Now remember, they don't have column heading because it's an array and not a table, but we can just know what each of the columns is for because we're making this data, and we can write that down somewhere and tell everyone else that's working on it. So we're going to store 2 columns in this information. We're going to have the price with and without VAT. So the first one's going to have the prices, and the next one is going to have them without VAT. So we've got prices with and without VAT. It's going to be the name or the variable name for our empty array that's going to have no information in, and then we're going to add in the prices that have been had the VAT removed, and then we can print it out. So that prints out first of all like this. So the prices without and with VAT are, and it's printed out that with and without VAT variable. Now it can also be done by having the arrays to be joined. Instead of telling it that we're going to get column 0 and column 1 being this and that, you can just join them together in a new variable called Z and just say add prices and prices array. And then when you print out Z, it would look like this. But notice when I've done it this way, which does the same thing pretty much as this line of code, these 2 lines of code here, just more efficient to have one line of code than two, but it's done it the wrong way round. So this time it's printed them out row-wise, and we need it column-wise. So it's printed it the wrong way around. So to get it the right way around, all you have to do is print z.t, and then it's got the same information here as it had there. Okay. Don't panic about that one. That's a slightly more advanced thing working with arrays. Just mess around with the code later. The more hands-on experience you get with it, the more comfortable you will get. So the next thing we're going to do is getting started with what we call pandas. And no, it's not the animal. This is actually working with data. So, Rosalind, good question. Does NumPy replace the long code you did previously? It doesn't replace all of it, but it has, NumPy is like going and getting a toolbox out of my garage that has a specialized set of tools in that I can rely on to do parts of a job. So it's got all of my drill bits in, or it's got my my set of screwdrivers in, and some of them are flatheads, some of them are Phillips screwdrivers that have a crosshead, or I've got for doing certain types of screws and other specialized things. It's really good for those things, but it doesn't replace the fact that you still need to do the job. Okay, if you want to screenshot that error, Annalise, by hitting print screen and put it in the chat, we can have a look at that. But just for based on time, and I don't want to take too much of Khaled's time with the next session, we'll just move ahead. So we're going to work with some data from the Hubble telescope, and then manipulate that and mess around with it slightly. Okay, last little bit, about 10 more minutes. So in the archive file that you got was a data file called Hubble data. So I'm going to put this here, and I'm just going to double click on that. And what it is a .csv dataset. If you double click on it, it might open it straight away in Excel. It might not. Now, comma separated variable just means that you've got data or information in there that is separated by commas. So if I zoom right in on this and open it in a notepad or a text thing, we'll see that we've got a column heading, this table heading, distance, and this one, recession velocity. This is data for the Hubble telescope, so it's looking at comets and things moving around. Yeah, we'll come to uploading the CSV file in a moment, Namagiri. So you'll notice for distance, it's got a value for each of the rows, and then a comma, and then it's got a value for recession velocity, and then it moves on to the next line and the next line. So for every line, because we've got 2 bits of information, distance and recession velocity, it'll have the first bit, comma, the second bit. And notice we've got a range of recession velocities and some different values for distances that are on an entirely different scale. So look, opening it in a text editor, it looks like that. If you open it in Excel, it'll look like this. Now, the data set you're going to be using for the actual hack is a bit larger. It's not big data by any stretch of the imagination, but it is bigger than you can open in Microsoft Excel. It uses up all of the rows of Microsoft Excel as standard and won't allow you to do any more. Interestingly, this is the same problem that the UK government found with track and trace, where they had a spreadsheet that had too many rows for Excel, and that's why it all crashed and didn't work to start with. So what we're going to do is get this data from our computer, upload it onto the Google computer, and then bring it into our Python code. So this data is going to be like the raw materials that we're going to use to do the job of fixing the hole in the wall. So it's the wood, it's the plasterboard, it's the paint that needs to go on. It's separate from the tools and the code and the stuff that does the job, but it's the data, the raw materials to do that job. So to make sure that I can upload that data from my computer to the Google Cloud computer, I'm going to hit the File folder. I'm going to hit this one that's got the up arrow. And I'm going to click on the relevant file and hit Open. It is a tiny data file with hardly any rows. It takes no time at all to upload. When I leave the website, close it, after 2 hours of it not doing anything, it'll shut down and stop using Google's computer. That will be gone. So I'd have to re-upload it every time I want to work on my data. So That file is there. It's not being brought into the code. I've not got it out the garage yet. I still need to go and get it out the garage, these raw materials, but it's there in the garage now. So just going to hide that out of the way, and I'm going to import pandas, which is a brilliant library in Python that allows you to work with table data. Just does loads of work for you and makes it your life really easy. You'll get really good at working with pandas over the course, because that's the most common way of working with tabular data. And then I'm just going to have a look at the starting 10 rows of the data called the head. And as much as sorry, the first 5 rows. You can look at the head of the data, you can look at the tail of the data, you can look at specific rows, but you always want to just look at the data, okay? I don't know if Marion mentioned yesterday, but your brain, as it stands at the moment, is still the most powerful pattern processing device in existence in the world. So it would be stupid not to use our brains and look at the information in front of us and start to think about what's going on before we tell our code to run and do specific other stuff that may or may not be the right thing to do. So let the brain that instantly pattern recognizes do some of the work for us. Okay. We can see we've got these distances, we've got recession velocities, and we've got row numbers. So it looks a bit like it did in Excel. So you might think, well, why are we working in Python then if we've got Excel? Well, as I mentioned, for the hack, you're going to deal with data sets that are too big for Excel. We're going to be doing AI models over the course, over the next year, that are too complex to write into Excel. So you need to have that flexibility that programming gives you, and the ability to work with bigger data that we can't just do in Microsoft Excel. See, you can view specific columns, and you can get the summary statistics as well. So look at the mean or the median of that. So if we looked at the distance, it's going to print out this line here, tell it to print out the distance data and then put a new line. /n just means new line after every row. Otherwise, it would just print it out all in one big long line all the way along here, and you have to scroll along. It just gets a mess. So this prints it much nicer. And if we want to get the mean of the data, then we use list line of code. So the mean distance, or we could look at the median distance. And although they're both summary statistics, they're not always the same. They're similar in this case, but if they're really different, then that's indicative that something weird's going on in your data, and you need to investigate that. Okay, Annalise, so your error was because you're running the code before the data has been uploaded. So if you upload the data first of all, then a bit like I did, then you should be able to run that line of code. So we can try and write code to find the median, the mean, and other stuff, or we could just say, Python, tell us what's going on with this, and it will describe it to you. It's not the most detailed description, but it's not bad to start with. And this is where I was saying things like this just make your life easier, because you don't have to write to tell it what's the standard deviation of my data of each of the different rows and print it out nicely. What's the maximum value or the minimum value? Just tell it to describe it for you. And people have written lots and lots of different toolkits and libraries and things with Python to do these jobs for us. It makes life nice and easy. So just hit data.describe. You need to put an open and close brackets because it's a function that's working on your data, and then it'll look like this. So we've got 24 rows in our data. The mean value and the median value, we've seen those already. The standard deviation, the minimum value, the value that's 25% through the data, value that's 50% through the data, or the median, value 75% through the data, and the maximum value. So what if we need to sort the data? If we want to sort it by recession velocity instead, because it's not sorted by recession velocity, we've got some negative values after our positive values, so we'd sort that out. Sorted by recession velocity, and then if we print out the tail rather than the head, it will look like this. That's the bottom elements of the table. If we wanted to look at the top end of it, then we could just replace tail by head, and we could hit play again, and it will look like this. But let's leave it as tail for now. And it's little things like this that I want you to try and do over the next couple of days with this code. Mess around with it, see what it does. Try and, if it breaks, that's fine, just undo, or just re-upload the file as I've given it to you. So Recession velocity means the speed at which it's moving relative to a certain frame in space. With compared to the Earth, what's its speed? If you compare it from a different frame of reference in space, then it might be moving at a different speed, so it needs to be the standard frame. Ultimately, that doesn't matter at all for the task that we're going to be doing with the data. We don't need to understand it too much for this instance. But for lots of cases, obviously, in the future, you would need to understand it much more. And I'll show you an example of that later on. So listing the data is okay, but it's more useful sometimes to just plot it. And if we want to do that, all we have to do is import the plotting library that we want, and then tell it to just plot and show the plot. And we see here it's plotted, distance is almost 0 the whole time, and recession velocity is much more variable. That is an example of an absolutely useless plot compared to this data, because distance isn't 0 the whole time, is it? We've seen from our data outputs, it goes from 0 up until 2, pretty much. 0.032 all the way up until 2, whatever that frame might be. So I don't have to pip install these because these are all exist on the computer, the Google computer to start with. So I don't have to worry about all of those. That's okay. If they weren't installed as standard on the Google computers, then we'd need to install them. So the previous example, there was some weird stuff in there to pull data from HTML and from Wikipedia and all that other stuff. That's not a standard. Okay. I could tell it to pip install and then it would just go, that's fine, but I've already got them, so I'm not going to install anything. So we've got this plot that's pretty useless because it looks fine for recession velocity, and we can see there's this general upward trend there in the data now that's sorted. So Alistair, if you're using your PC and you have a standard Python programming environment, it will still have a lot of standard tools and libraries and things, but it won't have everything. This Google one has more than your computer will as a standard, but not everything. So as you go through the course, you may find you need to install other libraries and things, but it's really easy to do. The lecturers will help you do that. So what we want to do is a plot on 2 different axes. And this is a section of code that you'll probably want to borrow tomorrow afternoon and on Thursday as you're working in groups on the hack activity. So I'm just going to run it because it's easier to talk about what it's doing with it running. And all it's doing, although there's lots of lines of code, all it's saying is I'm going to have 2 axes along the y-axis in my plot. One for distance, that's the red, and one for recession velocity in blue. So distance is on an entirely different scale, going from 0 to 2. Recession velocity goes from -200 to 1000, i.e. -200 being it's moving, the velocity is like speed in that direction of -200 all the way up into speed in that direction of over 1000. Is it going away from us or towards us? So that's how it could have a positive or negative recession velocity as far as the Hubble telescope is concerned. Anyone notice something about this data then? We've got 2 columns or features for each observation that we're making, each comet that's being looked at. We've got a specific measurement for distance, how far away it is, and recession velocity, how fast it's going. What's your brain telling you when you look at this plot? So observation would be every single row is an observation. Oh, that's a nice word there, correlation. Very nice, Annalise. What do you mean by correlation? Yeah, they move in tandem. Okay. So as you increase distance, positive correlation, yeah. So a positive correlation would be as we increase distance, we increase in recession velocity. Yeah, great. This is what we would call a linear correlation. It looks like a nice straight line. In reality, never expect to see something that's quite that simple, but take advantage of it if you do see it. So there's a positive correlation, as distance increases, recession velocity seems to increase. Great. So let's have a look at that correlation. Again, why would we write code to add them all up and find the variance and the standard deviation and find our own correlation, and not just use the Pearson R correlation function that's in the stats library there and print out the correlation? And the correlation 0.78, and the correlation goes from -1 being negative correlated, sorry, to positively correlated of +1, positively correlated. It's just camera angle, so negative, positive. And we've got a positive correlation here of almost 0.78 is almost 1. It never expect a correlation of 1 because something's wrong with your data, or it's not, or you're wasting your time doing something that's just far too easy. Okay, but 0.8 is really strong correlation. That's like golden. Okay, so if something's really highly correlated, we can use one of the features to predict the other one. And this is where we start to get towards the data analysis and machine learning points. And this is one of the last things we're going to do. So we're going to do a linear regression, i.e. we're going to have some function that is the, I'm just going to get this the right way around. We're going to predict recession velocity from distance. So we're going to say recession velocity is some number, A, times distance, plus B. And we need to know what those A and those B are. So we need to learn those from the data. Now, if you've done any sort of data analysis on previous courses and things, you'll have shown you the formulas and things to work that out. Again, why would we code that in when someone's done a perfectly good job of doing that for us? And we're just going to call up and tell Python to learn it. So we're going to get to the linear regress library tools from the stats library there. And U are going to be our variable that we're going to store the A and the B values in, or the linear regression things in. And we're going to use distance, and we're going to try and predict recession velocity. Print out U, and then we're going to say A is the first part of U and B is the second part of U in the list U. I'm just going to run this. So linear regression results, it's printed out all this information for us. That's all wonderful with standard errors and correlations and other stuff. That's a bit of a mess though. What we actually wanted was to get it to do this, find out what A and B are. Now we're going to test it. So if we get the element 10 of the list in distance, times it by A plus B, our recession velocity from our linear regression analysis should be 322. If we look at the actual data for row 10, that's 300. So we predicted 322 as a recession velocity, and it was actually 300. It's pretty darn close on a scale of like -200 to 1,000, being 20 out. Yeah, like a 50th out as far as the error is concerned, like 2% error on the scale of things. That's really good for like a quick, like one line of code, test it and off we go. But it's not always the case. So if we take the 15th element, multiply it by A, add B, and then compare to the actual. So our prediction was that it was going to be 413 recession velocity, and it's actually 920. That is massively out by a factor of 2. Okay, there's no hiding it. It's not great. The keynote of you might notice that I've specifically picked the points here. So 10 where it's almost perfectly aligned, and 15 where it's really far not aligned. But I'm doing this for illustrative purposes. So what we can do is try and normalize the data to make that slightly easier, but that's not overly important. Okay. There's some activities here for you to do after the sessions are finished today. So make sure that you can change the code that I've put in. Instead of saying hello world, print hello world, I love AI. Create a list with prices for phones like an iPhone, Pixel, Samsung, and an LG phone, as if you were a phone seller like EE or TalkTalk, for instance. See what the prices are of these phones when import tax is removed, 12.5% instead of 20% VAT. And see if you can swap around the variables and use recession velocity to predict distance instead of distance to predict recession velocity. And see what the values of A and B look like then. Okay. Does anyone have any questions? I appreciate I've talked a lot. I've gone through a lot in this, but hopefully it makes some sense and you feel like you've at least got the starting point for what to do and how to run this. Okay. First things first, just run it all through and see what it's doing and then mess around with it. And if you break it, doesn't matter. Just upload it again and try again. If you want to have a copy of it saved to your computer, once you've edited it, you can hit File and you can hit download.ipynb. So Craig, if you need help with any of the work, so this is all going to be self-directed in terms of messing around with this, but I'm going to be in the session tomorrow afternoon introducing the data set for the hack, and you will be using some of these same tools, techniques, and I've built up this notebook a bit further to import the actual data. Andre, would this recording be uploaded? Yes, it absolutely will be, and you should all have access to it after this straight away, because it will show in the chat, it will say, here's the recording. But just to make sure, I'll upload it to YouTube very quickly and then share the link for that. The whole hackathon is being recorded and will be uploaded to Mariam's site as well. So we'll make sure that's all done for later. But just so for quick reference, I'll make sure that you've got access to this. Yeah. So Ikra, you can find this file in the chat. So I put it in there to start with, and it was called archive 4. So just scroll right up to the top of the chat and you'll see the file there. Alistair, great question. Okay. I didn't mention this earlier, and I should have. So when writing code, particularly in Python, I don't get it right first time generally. If it's like 1 or 2 lines, fine, yeah. But if I'm writing like actual code to do a job, 10, 20 lines, 50 lines, it won't run. Like guaranteed, it won't run first time. And it takes me about 4 attempts normally to make something work. And sometimes it's really simple, like I've made a spelling mistake, and instead of saying print X, I've printed Y, and I haven't set up Y, I've only set up X. So it can't print Y. So that's one thing to start with. Is it a spelling mistake or an error? Run code in small batches. You'll notice that there's individual small code segments here that have the thing to do. If you want to create your own that messes with it or does something else, just hit plus code and it'll add an extra code segment here. You can copy some of the code and then paste it below and then mess with it there, so that you've still got the copy of the good code here that you know works, and then your modified version down here. Okay, or you can delete it by hitting delete. If it's something that you can't work out what the error is, then Google the error. So Annalise, you shared earlier a picture of your error where it hadn't got the file uploaded yet. So the actual error that was being said there is file not found error. So it's not always clear what the error is, but that one is probably because it can't find the information, so it's not been uploaded. But if it's something like it doesn't have this library or this library doesn't work, sorry, Google it. Copy the code, the error, and say Python or Google Colab, paste the error, search it. You'll find a website that comes up more often than not called Stack Overflow. It is an excellent source of solutions to coding problems from proper software developers and programmers. They're excellent there. So have a look at what people say. That shouldn't have created a problem, Annalise, because we were working on Google Colab, so that's on Google's machine. So that shouldn't have been a problem. Did you upload the Hubble data file? Interesting. So when did you click the upload for the files? Did you click the upload here to do the Hubble data one? Okay. I'll have a think about that and come back to you. It might be tomorrow in advance of the hack. We just need to get you to screen share quickly to see what's gone on there. But we can work that out. Okay, Ikra, what I'll do is just quickly get the link again and put it in the chat. So this is the link for everything that we talked about today in terms of the coding activities and the data form. So Adam, you'd asked about the timetable for today. So now I'm going to hand over to Khalid, who's going to be talking about data types and formats in particular, and data modeling. Then he wants to talk about regression after the lunch break, depending on how time goes. And then finally, he's going to talk about AI pipelines and a project that he's done. Okay. That is interesting, Annalise. That should work, but what I'd recommend doing is to restart your runtime altogether. So connect to a different computer on Google and start from the beginning of the code and work again. So if you click runtime, restart runtime, and then it will take you, you go all the way up to the top of your code, rerun everything up until that point, upload the file, and then try it again. Okay, so I'm just ready to hand over to Khalid to introduce the next section. I know Khalid, based on the audio difficulties and things, he's going to introduce himself again. But what I will just do is stop the recording now, so we've got the recording for this session, and then we'll start the recording for the next session shortly.